Hi, thank you. We had a little bit of difficulty trying to live stream with YouTube, but I think that we've got it worked out. So I'll make this brief so we can have more time to talk with our panelists. My name is Michael Young. I'm the PI of the Regional Induced Seismicity Collaborative, which is a collaborative of state geological surveys in the southern mid-continent of the United States. We were created to try and address kind of multi-state regional issues in geosciences that are really very difficult to do when everybody's sort of dealing with their own jurisdictions. And one aspect of risk, besides just the research itself, is to focus on webinars that are communicating to a variety of different stakeholders, from regulators to seismologists to other folks in industry and across the country and across the world. So we've had these typical webinars, where we speak at you all, but recently we thought, hey, let's try to mix it up and have a panel and really try to engage panelists with questions and then seek questions from the audience. And so today we're going to have our panel on the whole issue of produced water and what trends people are seeing. Kyle Murray from the Oklahoma Geological Survey has kindly agreed to lead our group. And with that, Kyle, I will hand this over to you, and I will be visiting toward the end of the webinar. And thank you, everybody, for being here and for spending an hour with us. Okay, take it away.
Thank you, Michael, and thank you to everyone for joining us today. I know that there are a couple other webinars going on right now. I was informed that there's a produced water related webinar held by industry today, and there's also one in New Mexico held by the New Mexico group. So I'm glad you joined us, and if you know some people that are participating in those other seminars or webinars, please let them know that this is recorded so they can view our panel discussion later. So I'm going to make it brief as well. I organized the panel trying to invite panelists from our 5 states that participate in the risk group. The 5 states are Kansas, Oklahoma, Texas, New Mexico, and Arkansas. So try to get a panelist from as many of those states as we could. Today, we have 3 panelists. I'll let them introduce themselves and describe a little bit about their background related to produced water. And then, of course, any connection to induced seismicity that they've dealt with in their work and professional life. The panelists are Bridget Scanlon from Bureau of Economic Geology at University of Texas, Austin, Ted Peltier from University of Kansas, and Steve Coffey from the Produced Water Society. So I'd like to hand it over to Bridget to get started. She'll give an introduction, and then we'll move into some Q&A.
Thanks, Kyle. I tried to share my screen with a couple of slides. Kyle and I wrote a paper a few years ago on induced seismicity in the major unconventional plays, trying to understand the causes of seismicity, and I guess summarized that most of the other major plays outside of Oklahoma were disposing in shallow zones above oil and gas reservoirs. Our group recently evaluated water issues related to oil and gas production in all of the plays. And in this image on the right here, you can see the projected produced water volumes for each of the plays: the Permian, the Delaware Basin on the left, the Midland Basin on the right, and the Bakken, Marcellus, and Eagle Ford. So the gray hemispheres are produced water projected over the life of the play, and the blue is hydraulic fracturing water demand. And in this study, we emphasized that the lowest hanging fruit with the least risk is reusing produced water to support hydraulic fracturing. And in most plays, that should work. But in the Delaware Basin, they produce almost 4 times more water than they need for hydraulic fracturing. So we need to consider other aspects to manage the produced water in the Delaware Basin. We did another study then looking at a potential beneficial reuse of produced water outside of oil and gas sector. And the major users would be, as we just mentioned, hydraulic fracturing, but also irrigation application, industrial uses, municipal discharge to surface water. And in the case of the Permian, that would be the Pecos River. And then others have suggested groundwater recharge. And in this analysis, we showed that produced water volumes would not substantially alleviate water scarcity, and they represent up to 10% of irrigation water use in the different counties in the Permian Basin. There are a lot of issues to reuse outside of the oil and gas sector, including variable water quality, up to 7 times that of seawater, and the intensive treatment that would be required to treat the produced water for use outside of the energy sector, and knowledge gaps in quality and regulatory limitations considered major barriers to reuse outside of oil and gas. I think we will be developing a consortium within Texas Tech. Danny Reiber will be leading that in Texas to evaluate these issues. And the New Mexico Produced Water Research Consortium has been looking at beneficial use outside of the oil and gas sector for the past year or year to 2 years. The last slide I want to show is the saltwater disposal in the Permian Basin and the trends over time. And you can see the line, black line showing the Delaware Basin, a large increase from about 2015, from 500 million barrels per year up to almost 2 billion barrels in 2019, and less of an increase in the Midland Basin. So that's all I wanted to show, and I'll try to stop sharing. Thanks.
Okay, thank you, Bridget. I want to make note that there are some messages coming through the chat from Dina and Michael. That just if you're not viewing the Zoom, maybe you're listening on the telephone, we can accept questions in the chat in Zoom. And Dina, maybe you can correct me here, but I think it's possible to ask questions through the YouTube stream. So please, if you have questions, enter them into the chat or save them and ask them verbally later. We'll pass it to Ted next, please.
Hello, thanks. So my name is Ted Peltier. I'm a professor in environmental engineering at the University of Kansas. My interest in produced water primarily is in sort of treatment and management, and looking at how and looking specifically at sort of dealing with Kansas specific issues. So I do have a couple of slides to share on the assumption that maybe everybody's not spent as much time staring at Kansas as I have. So are we good? Are you seeing something? Let's go with that.
Yes, looks great.
All right. So this is a map of basically the oil producing regions within Kansas. None of these regions quite made Bridget's map of major basins, and rightfully so. But from our standpoint, major production areas are sort of in the south, central, and southwest, and then in this central uplift region here. What we see in terms of generation and management, the volumes have actually stayed, well, this timing sort of misses the peak that we probably saw in 2014 or so, but the volumes of produced water generated are high relative to the amount of oil produced. Kansas is a top 5 generator of produced water, but not of oil. We have very wet systems, and averages are around 20 to 1 or so for water to oil. So we generate a lot more than can be probably easily reused within the oil and gas industry. At this point, about 75% of that goes into subsurface disposal. The rest is mostly used for enhanced oil recovery. This is a little bit of a breakdown in production by county. This is estimates generated from oil and gas data, and then making some assumptions about, you know, water to oil, water to gas ratios. But it shows about what you'd expect, which is the major oil producing areas are those with for the most part the major generation, and generally we see about, you know, the numbers for underground injection about line up at typically around 3/4 to 80% of these, and in a similar pattern. This red box down here, I'll come back to in a minute. So this is where we see earthquakes in Kansas. And that red box essentially covers the same 2 counties as one of our major sources. And this is the area in Kansas specifically where restrictions on injection rates and volumes were put into place starting in 2015. The other area where we've seen somewhat more activity lately, this area does sort of correlate with the central uplift region. This one is rather separate. There's been some additional study here by the Geologic Survey, who I work with, but seismicity is not my major issue, so I'm not going to try to expand too much on their findings, except that there is some indications that there may be some sort of longer term migration or effects of wells at longer distances over time that they've seen sort of outward from this region, from the Sumner and Harper County areas. So what we're really looking at is trying to find a way to deal with these water volumes and find some use for them that doesn't involve basically re-injecting them back into the subsurface formations. Most of it in Kansas goes into the Arbuckle Formation. We've seen signs that the pressure is rising there, that space is essentially limited. So we're looking at 2 major things. One is trying to use lower salinity waters in higher salinity formations water flooding is still a fairly common practice in parts of Kansas. And so we're looking at the sort of the geochemical compatibility and the effect on oil recovery of using up to say 40 to 50,000 TDS water as water flooding in formations where the salinity may be 100 or 150,000. And so essentially trying to get some secondary use out of those, decreasing somewhat the overall volumes that wind up being injected out of this process. There's also been a great push, of course, to look at using it for other water intensive industries in Kansas, which are primarily agriculture. The amount of produced water generated compared to irrigation agriculture is quite small. But if we see here, and this is for Western Kansas, and then for sort of the Anadarko region, this was a slightly different study we've been working on. The volumes of produced water generated match up relatively well with livestock use, which is a major industry in southwestern Kansas. Not that very much of this would be usable without significant treatment, and so we are looking at what's the possible treatment requirements and economics of that. But that looks like an area where you could have potentially a significant effect. And I'm going to stop there and turn it over to Steve, I think.
Yep, thank you. Well, thanks for inviting me to the panel today. It's always been great to reach out to people, and I think today in this virtual setting, we can reach more people and a wider subset of people. I know these virtual events can be quite tiring and also technically challenging sometimes. And I know we're all very eager to get back into the real world and see our colleagues in real life. And I feel but I still feel that this sort of event offers really great value. I think it fits well into the world today that we live in, and a lot of reaching more people and spreading education in a easier, quicker way. I've been in produced water for 27 years. I'm still very passionate about finding new approaches and new ways to address issues today. The industry has really changed, continues to change, and then some things have stayed very much the same. But finding ways to increase production, reducing production cost, and meeting today's environmental challenges and responsibilities for production companies is at the top of my list. So a lot of what I do is in the realm of produced water treatment. And recently I've been elected to the president position of Produced Water Society, which is a nonprofit, Texas-based organization serving water professionals in the oil and gas industry. This is my second term. My last term was served back in 2017 to 2019. I've been active in the society since 2006, and found it really a vital part of the global produced water community, but also from an educational standpoint, it's been great to have colleagues and a lot of peers challenge ideas and ways of doing things. We've focused at Produced Water Society on produced water education, and we're dedicated to improving produced water management to the benefit of the environment and to the industry by fostering these dynamic discussions and whether it be virtual or in real life, and discussing opportunities for water and the different areas that we can touch and learn from each other. This is our 31st year with the Society, and we have recently just joined into an agreement with Groundwater Protection Council and the Groundwater Research and Educational Foundation, and this will definitely strengthen our collective reach to the U.S. Water sector. This teaming is already, I feel that it's already been very beneficial in the sharing of information and the potential for sharing membership services. I think the synergies that we have as nonprofit organizations will only increase as we go forward in this year ahead with some live events and some shared co-events, but also reaching out to others that touch groundwater and produced water. There are I think, a lot of overlaps, not only between the people, but also the technologies and the goals. And I feel strongly that working together with these sort of groups will only enable us to do more for ourselves and our companies and our communities. The Produced Water Society will be launching its first ever membership drive next month, once our new website is up and operational. A little bit of a technical glitch this month, tried to try to switch things over and make things more relevant for today. But we're excited to continue to offer a home for all of our produced water members that have been longtime members, as well as a lot of new members who we've not reached or touched in the past. I think the Society offers a lot of membership services for individuals and for companies and to our community. So hopefully you'll be keen to join us and share in more of these sort of educational sort of ventures. I also wear another hat as Exterion's Director of Market Development for where we focus on turnkey solutions globally for produced water. And with that, I will stop talking, but I'm just very happy to be here and excited to be a part of this. I haven't touched on this topic in a while, so it made me think about a lot of things. I know a lot of you reached out yesterday when you knew that I would be here today talking about some of the thoughts and challenges that you had. So I appreciate everybody sharing those. I think the year ahead will be very exciting. I think there'll be a lot of challenges and opportunities for us. And hopefully today we can kick that off with some great questions and discussions here in this panel discussion. So I appreciate everybody tuning in for this today. Thanks, Kyle.
Great, thank you, Steve. I'd like to kick off the discussion with a couple of questions that I have, and then we can go around the table and entertain some questions from other risk members and then the participants in general. I liked seeing in Bridget and Ted's slides the saltwater disposal rates and trends over time. And Bridget, you also included some information about hydraulic fracturing, fluid volumes. And so this group, the Regional Induced Seismicity Collaborative, has focused over the years on injection-induced seismicity, maybe starting with saltwater disposal being that form of injection. But I think we're learning that hydraulic fracturing is also a potential way to induce seismicity. And then we're going to be faced soon with even water flooding potentially as a means of injection-induced seismicity, even CO2 floods and CO2 sequestration down the road, maybe gas storage or even hydrogen storage. So I guess that's a lot to chew on at one time, but let's talk about the saltwater disposal rates and the seismicity trends in general. Bridget, you showed some charts that on the Permian Basin, Midland it looked like, and the Delaware Basin. Can you tell us in general for the state of Texas, what the saltwater disposal trends are and the seismicity trends? Maybe when did you reach a peak disposal? When did you have a peak seismicity? So for example, in Oklahoma, it's pretty easy for me to say that the peak disposal rate was in late 2014, early 2015, and the peak seismicity was in 2015. And it's been decreased, both seismicity and saltwater disposal have been decreasing since 2015. So Bridget and Ted, could you address in general what it looks like in your states? Bridget, you're muted. Bridget, you're still muted.
I'm sure that's the way a lot of people would like me to be most of the time.
Never.
So the graph that I showed earlier indicated that in the Delaware Basin, the saltwater disposal increased from like 500 million barrels in 2015-16 to 2 billion barrels. So that's a factor of 4 increase in through 2019. And there's a year delay or a year lag with reporting. So that's the most recent data that we have on an annual basis. So you can see that disposal has been increasing quite a lot, particularly in the Delaware Basin. The Delaware Basin produces about twice as much water as we need for hydraulic fracturing, whereas the Midland Basin, the produced water volumes and the hydraulic fracturing demand are matched on an annual basis. As far as seismicity goes, I haven't been following that closely, and maybe Michael or Jim or somebody else might chime in. But I do know there had quite a bit of seismicity in February this year west of Big Spring, with a number of earthquakes very close together, the 3s and 4 maybe, and then also in the Delaware Basin and also in New Mexico, but that is not my area of expertise. But I did hear Phil Getz indicating that in New Mexico they had 2 locations in Lovington County and also further south along the Texas-Mexico border, where they had seismicity in a linear trend. And so I think they're seeing increased seismicity, and some of it, I think in Texas, they can't link directly to disposal. The Mentone sequence is fairly distant from the most, from disposal. So they're still trying to figure out what's going on. In the Midland Basin, Alexandros Savaidis showed that both the fracking, hydraulic fracturing and disposal were linked to seismicity. And I think they're still analyzing the data in the Delaware Basin.
So in general, the saltwater disposal rates are still going up in the Permian Basin region.
Right.
And seismicity probably is also increasing.
Right.
Okay. And Ted, maybe you can touch on Kansas and where we stand there.
Sure. More similar to what you described for Oklahoma. I think our it depends a bit on the region, but probably the peaks were around 2000. The peaks are likely around 2015 in most of the areas we looked at. Some of the older areas that have been in production longer are just more sort of flat across that time. But a lot of the areas where unconventional techniques came in peaked around. Injection peaked around 2015, has been down since, at least partly. A lot of that's economic driven.
Right.
So the regulations that went into place in South Central Kansas have not had as much of an impact as they might because because of that drop off in production. Seismic activity, I think. I probably shouldn't say much at all with Rex on the call here, because I think I have a good sense he knows more about that. But my general sense is that we did see a bit of a drop off after 2015, sort of into 2015 and 16. A little less clustered and a little less centered around those large injection well areas in the following years after that. I don't I have not kept up enough to know what sort of like the last year or so looks like at this point.
So in Oklahoma, when we were at our maximum or highest or peak disposal rates and peak seismicity, our state, a group of regulators, researchers, government agencies, state agencies, put together something called the Produced Water Working Group. And one of the main incentives of that group was to help in mitigating seismicity by finding ways to reuse water. So let's take the Permian Basin as an example. And let's say we wanted to decrease disposal volumes and hopefully mitigate seismicity as a result of that. What might we see in the future, new technologies that might help us? Steve, maybe you can address that question. Are there some emerging technologies and some active produced water treatment projects going on in this, South Central or Southern Mid-Continent region that would help us to continue to mitigate seismicity?
Sure. Yeah. From my viewpoint, I think that the impacts are very similar to produced water treatment. Since disposal really remains easy and cheap, and what folks are used to or comfortable with, I think regulation and seismicity, the challenges and practices, I think will have little impact for now on changes or how we treat or think about seismicity. Technology-wise, I definitely think there are a lot of opportunities for growth. I think a lot of what it has to do with, and I can talk on this topic for a very long time, but I think that the major takeaways really would be a lot of the technologies aren't really necessarily new technologies. I think they're existing technologies. I think they need to be used in the right place. I think they need to be used in the right, sizing them correctly and used for the right purpose. I think using products that are fit for purpose and treating things in the right, at the right time in the right place is very key. So I think a lot of the quote unquote technology aspects are going back to the basics and foundations. I think what the lessons learned from other areas and also other, let's say, conventional market, there's a lot to be learned. Things that I've learned, especially let's say regarding solids or chemical treatment. I think there's quite a bit that can be learned taking a look at another geographical area or another type of oil and gas production. If we apply these sort of lessons learned to what we're talking about here, I think we can go a lot further. A lot of it is just, I think, the market grew and there was, the infrastructure wasn't in place, the people weren't in place. It was a typical bust boom sort of situation that kind of got us into this, into some deficits. But I do see the encouraging part is I'm seeing more people come from other places that bring new perspectives and new experiences and knowledge. So I do think that the innovation and technology part of it, even though it may not be new, I think we're seeing more and more of that taken advantage of today, and hopefully that can be applied and used and thought of in a real use and practice standpoint.
Before the global pandemic put an end to travel for conferences and workshops and meetings, for me, I attended a lot of conferences in Texas, and in Permian Basin was a hot topic. And one of the things that I noticed in those conferences were the emergence of midstream companies that were handling water and taking over the management of water from oil and gas operators or producers. And I wonder how that trend has continued in Texas and the Permian Basin, or has it developed more in other regions like over in New Mexico or up in Kansas? We don't have a lot of active midstream companies in Oklahoma, but there have been a few cases where water recycling facilities have been offloaded from the operator to a water management company. Do you guys have any feel for how that's going in terms of water management, and is it the operator that's handling it now, or is it more of a passed over to the midstream companies?
I'll try to take a stab at that, Kyle. I think there are a lot of midstream companies, and that should help a lot with managing produced water, because the biggest issue is resolving spatial and temporal disconnects between produced water supply and frac water demand. And so the midstreams then are buying up pipelines and expanding pipelines to transport produced water to frac water demand centers, and also storing produced water in ponds to resolve those spatial and temporal disconnects. So I think that should help a lot with reusing produced water within the oil and gas sector. And to go back on some of the things that Steve said, I mean, I think the industry has evolved a lot over the since unconventional development by recognizing they could use produced water directly for hydraulic fracturing with minimal treatment and using a clean brine. And so I think that helps a lot. And the other thing is, what is the quality of the produced water we are dealing with? JP Nicole did some studies in the Permian Basin showing that some of the produced water in the Wolfcamp is 25 to 50,000 TDS. So we could use reverse osmosis to treat some of that, but we need to understand the spatial variability of the produced water quality in order to figure out what the appropriate technologies are to treat it and what would be economically feasible.
I think the growth has been slower in Kansas, probably even in Oklahoma, definitely than Texas. A lot of the producers here are relatively small and relatively fragmented in terms of small number of operations. So in many cases, in many cases, ideally they will own their own disposal well as well, which makes it sort of hard to compete with for disposal on a price issue. There are some companies that have started operating here, but I think it's moving much more slowly.
And before I answer the question, I was just going to touch on what Bridget had just said about parameters and guidelines. Produced Water Society has published, and you can find this online, produced water guidelines specifically for unconventional. We collected about 30 of our members from different organizations to come to an agreement, which is, you can imagine 30 different people and organizations have come into an agreement on standards, and we decided not to call it a standard because we weren't at that stage. But I think having guidelines with ranges that let's say 80–90% of us could agree on as a target was a good first step. So that was a major accomplishment. It took almost a year to develop a consensus on what some of these produced water and brine guidelines were for specifically for the unconventional market. But on the midstream topic, going back to your question, Kyle, I think one of the most interesting, the market's quite convoluted and a little bit crowded, and there's a lot of uncertainty still. But one of the most interesting things I've seen recently was what Solaris Midstream has done recently. They just completed a $400 million offering of unsecured notes for the first ever that I know of sustainable linked bond for produced water infrastructure in our industry. So I think things like that are, you have to have the funding to make things happen. Infrastructure was one of the early day issues for why things weren't happening. So I think this sustainability linked bond will really help change the way that we look at recycle reuse. I talked to Amanda Brock recently, who is Solaris's CEO and CCO, and she was, really, is committed to recycle reuse in the Permian Delaware, and it sounds like they have a good plan and now funding to make that happen.
I'm seeing a couple questions and comments coming in through chat, so I might jump over to those and get you started on responding to some of those as well. I think I want to read the comment that I see at the bottom there. Hi, this is from Carrie Ridley. Hi, Kansas Class 135 and hydrocarbon storage regulator here. Our midstream companies have their own Class 1 disposal wells to support their storage operations. They don't take off-site produced water. So Class 1, Class 1 operators are certainly different than Class 2 operators. But it sounds like the midstream companies are not necessarily doing a lot of commercial collection. Let me go up to Michael's question. This is maybe one of the things that we as risk members really are interested in. What are the largest gaps in knowledge for regulators and industry so that they can make better decisions in this sector? These are some of the things that we want to address as researchers. What types of data are needed to fill these gaps? And I think I had a question similar to that. So what are some of the biggest challenges that we have in managing produced water, managing fluids in general, specifically to help mitigate the problems that we have with induced seismicity? Bridget, you touched on the produced water quality issue, but are there some other issues that we have? Steve, you mentioned regulation as well, and I'm not clear on if that's a problem. That's been a problem for industry or not.
Yeah, I pulled. I was looking back at some notes from a while back, and I was helping a colleague with on this topic, and I pulled a presentation from 2012, and then again one that I presented. I think it was 2018 for Texas desal, and a lot of the obstacles for reuse and the challenges that we're talking about here today, a lot of them are policy driven. I think some of them have to do with water rights. Liability comes into play. I think solutions is the part of that. I think having a good total solution is important. I think we touched on this earlier, Kyle, the operators deciding if they are in the water business or in the oil business, or if they're going to manage the water, or are going to let third parties, take this. And I think some of the midstreamers have tried this. But I think there's a lot of, pitfalls. But I do think also a lot of it has to do with not tracking the data. I think, monitoring, recording, and tracking to make good information. And there's so much data today. It's like without stepping onto a scale, how do you know that you need to go to the gym? But today there's no reason not to do this. So we have the tools to do it. So I think part of it's the next big challenge is to use this information that we have, that we're starting to collect and starting to track, and not only for trending, but also put together a plan to come up with a way to solve the problems in a better, more scientific way. But also the human part of it that's going to be the harder part, I think, is not being afraid to change or do something different. I keep hearing this is the way that we've always done it, and I probably even said it once before. So it is easy to do what you've always done. So I think that change of mindset might be one of the biggest obstacles to overcome, not so much the technology or the tools. So I think that might have a big impact on how we regard water management in the context of induced seismicity.
Maybe I can add a little bit to that, Kyle. I mean, you mentioned early on all the fluids we're considering of putting in the subsurface, produced water, CO2, hydrogen. We need to understand the disposal capacity in the subsurface. And so I think, and do reservoir modeling and stuff to understand what the impacts of different operations would be, and spacing and vertical, horizontal, all of these sorts of things, pressures. So I think that would be really important. And as far as management goes, I think for producers, optionality is very important, because things can change, either regulations or seismicity or other things. So it would be good for them to have different options for managing the produced water. I think we're seeing some of that in the Permian. I think operators are sharing produced water among each other for fracking to increase reuse. Groundwater Protection Committee, Steve mentioned tracking and monitoring, is going to have a new slot, or make it more readily apparent when producers reuse produced water for hydraulic fracturing. So we'll be able to track that more readily in the future. So water quality, water quantity, and then all of the other things that we're considering doing in the subsurface in the Permian as we go into energy transition, or what might occur in the future, hydrogen or CO2 sequestration or other things.
Bridget, before we move on, maybe to Ted's comments, in Oklahoma, we have the Oklahoma Corporation Commission has set up a system that they call AWESOME. I can't remember what the acronym stands for, but it allows them to see in pretty much real time the injection rates and seismic activity in Oklahoma. Injection rates are daily reports from operators that are disposing into the Arbuckle, specifically in the area of interest. And then the seismicity data comes from the Oklahoma Geological Survey's catalog. They also have frac notice information from operators. They have to provide a notice when they're getting ready to do a hydraulic fracturing job. So in Oklahoma, we're essentially able to make some decisions in real time or on a daily time scale. I'm curious if Texas has evolved to that kind of system. Do we have the data from industry, from researchers to help regulators make decisions in a short time frame?
My understanding is that when there is seismicity in a region, then operators provide the data on a short with a short lag time, and we have the TexNet Scissor group, who records the seismicity, and that's provided daily. So I think when there is seismicity evolving in a region, I think the operators work with the regulators and others to provide the data in a timely fashion. Maybe Jim Moore might be able to provide, or Michael might be able to provide more detail on that.
Okay, just curious.
Sure, I can comment on what Texas is doing to track seismicity.
Yeah, please do.
I think it would be easier for me if I could share my screen, but I'm not sure if I'm set up to do that as a participant.
Dina can
might need Dina's help too.
I am trying to find his name on the list,
Thank you.
but it's not in order. This is Jim Moore, correct?
Correct.
Yes.
And I saw Aaron Velasco was joining the call not too long ago. If he's still on the call, he might.
I'm in.
Yeah, he might be also able to
I
comment
do
on
not
that
see
as
Jim's
well.
name on the list.
I can comment to it. So there are a fair number of things that are ongoing that are still evolving. In some areas of Texas, we've designated certain regions where we're requesting daily volumes and pressures, for example. And in specific cases, especially where events of interest, we have asked for well completion information. That's openly available. It's not throughout the state, but it's in specific targeted regions as we speak. Does that answer your question, Kyle?
Yeah, so it sounds like you're kind of moving in the direction that Oklahoma has, where you're getting a little bit faster response than then, Bridget said there's a time lag sometimes with the data from a researcher standpoint, but from the regulator standpoint, you're getting the cooperation from industry to get the data in hand and make decisions.
Yes, and in fact, I would offer that we've gotten really good cooperation from industry to gather that information in specific areas. And so the normal regulation is that they report monthly volumes, but on an annual basis. But in other regions, that is not the case. We are asking for information to be voluntarily given to us, and in many cases, most cases, in certain areas, we've had 100% compliance. In other areas, not so much. But we're getting there.
Yeah, great.
So I think I've got capability to share a screen now, if that's appropriate. If we have time.
Yeah, we are getting close to about 10 minutes here. So if you got a minute or two of some info to share, it'd be great. And I don't want to leave Ted or Steve out if they have comments too. Trying to share, Jim?
Well, maybe while
What-
Jim is trying to get his screen, maybe Ted or Steve can provide some.
Is it anything showing up?
No.
No,
No,
Not yet.
there's coming.
There you go.
All right.
How about now?
Now we see it.
Yeah.
Yes.
yes.
So this is a pretty busy map, but this is the one that I would like to select. It does show the Permian Basin and the Midland Basin, Texas, and Mexico state line. A lot of colors on here, but this is our tracking system. So the earthquakes are in green and orange colored. These are filtered at 3.0 magnitude and above. And then we've identified some areas inside the green dotted lines that have a 3.5 magnitude or above. The blue dots in the background are the injection wells in our system. And so this would include all active, canceled, plugged, all secondary recovery, disposal wells. So just any kind of injection well is the blue dot. There's a fault layer, which is the latest and greatest fault layer from the BEG. And so there's two areas shown, actually two kind of merged here, and the second one here with a green dashed line, which is approximately a 25-kilometer radius around the 3.5 magnitude events, and then it's spread to mimic the pattern of the 3.0 events. And so if you can see some red and blue boxes showing up, that's indicating daily H10 data that we collected. And so that was our successful cooperation with operators that Aaron was mentioning, and I can show a chart related to that. So shows here at the bottom that of active wells in those regions with the green dashed line around it, we got responses of about 193 wells that provided daily data all the way from November of 2019 up even to the present day, and they're continuing to send that in each month. And it does then include 180 wells that the operators responded to with a clear statement that the well was not drilled or not active.
Okay, that's good. That kind of addresses the question that Texas and in the Permian Basin specifically, where there are some concerns about induced seismicity, there's pretty quick turnaround for researchers and regulators and industry to collaborate on that and help to mitigate the problems. I think unless Ted or Steve has a response that they're dying to contribute, we might want to shift and take the couple of questions that we have on YouTube. Is that okay with you, Ted and Steve?
Sure.
So Aaron from BEG, I think Dina has you pegged with reading those questions, and then we can try to get responses from our panelists.
Sure. So we've got a question here from Jonathan Henson, who says, in studying saltwater disposal and seismicity, are the varying disposal depths being accounted for? E.g., a barrel injected in the San Andres will have a different effect than a barrel injected in the Ellenberg.
Yeah, I know Bridget has some insight on that one.
They do take into account, and JP Nico and others and June Hui are developing reservoir models, and so they have all of the data on the vertical distribution of the injection zones and how much water is going to each zone. And New Mexico has stopped allowing wells in the shallow zone in the Delaware Basin, the Delaware Mountain Group, and also in the Ellenberger. So that's restricting the zones where they can inject saltwater disposal to more like Silurian, Devonian, or other units.
Great. Aaron, we have a second question?
Yeah, we've got one more here.
Okay, great.
Arnold Biershank asks, Kyle briefly touched on other potential seismic triggers beyond produced water, such as CO2 or hydrogen. Is there a large push to sequester CO2 either as EOR or pure storage? And then he continues, the areas being heavily looked at are reservoirs, which may be in the same areas as depleted oil and gas. Are these areas already seismically active, being discouraged for CO2 disposal?
That's a tough question and a whole new panel. But Ted, did you have something to comment?
I mean, I know that there are people, and I know that there is they've been looking in Kansas's CO2 storage for storage. There have been several projects looking at that. I don't have the answers to the more complicated part of the question, so I'm going to, which is why I decided I wanted to answer first with the easy part. But yes, I know they are looking at it. Usually they're looking at either doing it into formations where you can inject with relatively low pressures, or in some case possibly in areas which have seen depletion already because of previous activities. I mean, those are sort of the two areas in Kansas that they've been focusing on. In terms of how that relates to specific seismic activity in those areas, that's beyond the detail I know of the project.
I think I can make a general comment on that. It seems like in Oklahoma and in Texas, the primary target zone for carbon sequestration or formation group is the Arbuckle group, which obviously immediately raises red flags in terms of induced seismicity, because that's the zone that we have restricted and taken. The Corporation Commission has issued directives on disposal into the Arbuckle. So CO2 sequestration into the Arbuckle, although in concept it might be the best zone for long-term storage of CO2 or any other carbon-based fluid, which I like to call them. It's going to be difficult to get over that hurdle, I think, in terms of induced seismicity and the ramifications of that new type of injection. That doesn't mean, in my opinion, that we shouldn't consider it and do a lot of research on that topic and learn as much as we can about it. There are lots of comments coming in and maybe even some more questions, but I'm afraid we're running up against 3 o'clock. So I would like to go ahead, Steve.
Quickly out there, Laura Capper, just in response to that last question, because it was really a great one, but maybe a difficult one to answer, but maybe just to throw something out there. Laura Capper with Energy Maker and Cap Resources published a couple of reports recently on this topic. One specifically on injectability capacities and the other on bottom hole pressures that touch on a lot of the topics that we just skimmed over. So I think even on LinkedIn, if anybody wants to go up there and check some of those out or email her, probably can get more information on that topic specifically.
Yeah, I'm gonna wrap it up here, and I know that we're recording this. We will record the chat questions and comments and try to address them. The risk members will try to address them with the participants. But I want to turn it over to Michael Young for some closing remarks and, some information on the next webinar that we have coming in August.
Great, thank you. And thanks to the panelists for all your comments and for being here and for the comments by the audience. There's never enough time, I don't think, in 4 years we've ever actually reached the end of the webinar and not had questions still. So this really shows, really sustained interest in this topic. And so before leaving, I would be remiss in not mentioning that that the risk is being funded by the Groundwater Protection Council through a grant from the DOE NETL office and the Fossil Energy Office in Washington. And so we're super grateful to them for their ongoing support to make this possible and to be able to communicate to you all with these webinars. The next, so we've been trying to alternate between panels and kind of traditional webinars. And so in August, I think third week in August, we will have a webinar by Lisa Block, who is with the U.S. Bureau of Reclamation. And she's going to be talking about the Paradox Valley unit in Western Colorado, which is a large scale injection project that's been around for about 25 years. And she's going to kind of talk about the operations in the western part of the US. It's now a big deal given the drought and the intention of what the Paradox Valley unit is really intended to do. So that'll be really interesting. That'll be in August. And then we will have another a panel on seismicity that'll be in October that Paul Aguara from the Oklahoma GS will be leading. So with that, I will close. I wish everybody good health and a summer, a good summer, where you can get outside and be with people and all that. Very important, especially now that we're kind of coming out of the pandemic. And thanks again to the panelists. Really appreciate your time and your thoughts, and also to Aaron and Jim from the Railroad Commission for helping. I mean, these kinds of interactions are what we're trying to promote. So thank you again, and to Aaron and Dina for all the tech support, which makes this all possible. Thank you again, and take care. Goodbye.